up, what up? I'm the math teacher goat, and today in AP Precalculus land, we are hitting another full lesson. And this time it's 1.9, rational functions and vertical asymptotes. Please look at the description, download the notes, or at least say that you did. Leave a comment, like and subscribe. Watch all of my other videos and tell people about me because you love me so friggin' much. And you know what I love so friggin' much? Rational functions and vertical asymptotes. So let's jump right into it, shall we? Here's our warm-up. Good old familiar stuff. I'm giving you a rational function factored in the numerator, not in the denominator. I care about the domain, I care about the wholes, I care about the zeros, and I care about the vertical asymptote. So it's already factored upstairs. Let's leave it be. X plus 3 and x plus 5. And on the bottom, we can pull out an x, and that leaves us with x plus 3. Let's use the zero product property to name our magic numbers, which is -3, -5, 0, and -3. Now, if you have a factor upstairs whose magic number is the same as a factor downstairs, that is a whole. So x equals -3 is going to be a whole. Let's just write that out. Okay. If you have a factor upstairs that is not seen downstairs, that is a 0. Don't know why I wrote that out when I didn't write out whole. It's the same letters, but it's too late and I'm committed. So my 0 is going to exist, my 1 0 so far is going to exist at the x equals -5 point. And on the bottom, we have 0 where 0 is not seen in the numerator anywhere. That is a vertical asymptote. And so that happens at the equation x equals 0, the y-axis. Okay? Now what I didn't talk about is domain. The domain is any x value that will not allow the domain to be 0. I'm sorry, the denominator to be 0. The domain is any x value that will not allow, wait a minute, hold on. It's any x, it's all the x values except the ones that make the denominator equal to 0. Words are hard. So if I look at the denominator being 0, 0 does that and -3 does that. So my domain is going to be everything except for 0 and -3, but that's not how we're going to write it out. That's not how we're going to write it out. We're going to write it out as everything infinity all the way up until -3, but not including -3, union, from -3 to 0, union, and from 0 on to forever. Okay, that's our domain, and that's our whole, and that's our 0, and that's our vertical asymptote. And here is more stuff. Build a factored rational function that has a whole at x equals regular 2, a vertical asymptote at x equals -3, and a 0 at 4. Well, hold on. We just did the backwards of that. I factored this and gave you the information. The information came from the magic numbers that we got when using the zero product property. Well, now I'm given the magic numbers. These are my magic numbers. Okay, so I have to build the rational function. All right, so let's do this. Let's do the magic numbers first. Build a factored rational function that has a whole at 2. Well, if there's a whole at 2, I'm going to have a magic number up here and a magic number down there, which means the factored version of it is the opposite, x minus 2, x minus 2. Makes sense? That's my whole. If the vertical asymptote happens at -3, that means you're going to have the magic number in the denominator only. So the factor for that is going to be the opposite, x plus 3. And if the 0 is going to live at regular 4, that means my magic number lives in the numerator only, and I'm going to have a factor of x minus 4. Okay? Whole lives at 2, x minus 2 over x minus 2. Vertical asymptote at -3, x plus 3 on the bottom, and a 0 at 4, x minus 4 on the top. Now, we've talked about limit notation so much before. Now let's talk about one-sided limits. So this is something that you're going to see heavily in regular calculus when you get to regular calculus. Okay, a one-sided limit says I'm going to have like a piecewise looking function thing, or maybe an asymptote, a vertical asymptote of some kind, and I care about what's happening from the left and from the right. Okay, so the way you write out the from the left limit is if I were to say, and I'm going to use 1 in this case, the limit as x approaches 1 from the left is going to be a little negative on the top right of 1. This is not negative 1. This is red, the limit as x approaches 1 from the left. Now what that means is I start from the left and I travel towards 1. Boop. And so I would say in this case, the limit as x approaches 1 from the left of, let's call this y, because why not? As I move from the left and I go towards 1, I line myself up with 1 right there, so the answer is 1. Okay, so again, let's clean this up a little bit. The limit as x approaches 1 from the left means I start from the left side of 1. I go towards that 1, and whatever it lines up with up here is going to be my answer. So you guys are smart. If I were to write out this guy, the limit as x approaches 1 with a positive sign on the top right, that means I'm approaching it from the right. So I go to the right of that 1, okay, and I go towards it from the right. I go towards 1, and that seems to line up with 2. So I would say that the limit as x approaches 1 from the right of y is going to be 2. From the left, from the right. And you get 2 different answers here. And you'll learn what that means when you get to calculus, because that means something very important. Okay? That's the end of that page. Let's go to the next one. Now, vertical asymptotes have one-sided limits that approach infinity. Now, what that means, well, let's be careful. Positive or negative infinity. Okay? So vertical asymptotes have one-sided limits that approach positive or negative infinity. Describe each vertical asymptote using one-sided limits. Okay, so let's go from the left first. Let's write out, and these will all be of y, the limit as x approaches. So what we want to do is describe each vertical asymptote. Well, I have one vertical asymptote at -2. So I'm going to go the limit as x approaches -2 from the left of y. The limit as x approaches my vertical asymptote from the left. As I go from the left, I'm heading downward, which tells me that the limit as x approaches my vertical asymptote from the left is going to hit negative infinity. As I go from the left to my vertical asymptote, I dip down and go towards negative infinity. So my other vertical asymptote is still going to be to -2 from the right side. So the limit as I go towards -2 from the right curls up here, which is going to be positive infinity. Let's do it again, knowing very well that I have 2 vertical asymptotes to deal with here. So the limit as x approaches one of my vertical asymptotes, which is going to be -2 again, from the left of y. As I go towards -2 from the left, I shoot up here, which is going to be positive infinity. Using -2 again, my limit as x approaches -2 from the right side is I go to the right of -2, and as I go towards -2, from the right, I'm shooting downward, which gives me a negative infinity for a limit. My other vertical asymptote is 4. So I care about the limit as x approaches 4 from the left. As I come from the left, I'm going this way, and I'm shooting downward, which means it's going to be negative infinity. What color didn't I use yet? Blue. And my limit as x approaches my vertical asymptote from the right side is going to have me going from the right. Here I go towards 4, and it shoots up at positive infinity. Okay. All right. All right. graph the equation on a calculator to understand one-sided limits from a table. So what we're going to do is we're going to take that guy, we're going to go to we'll do our TI-84 plus, because why not? We'll graph it on our TI-84 plus. We'll see what the picture looks like, and that'll help us get a nice visual here. Okay, let's go and do that now. Well, let's type everything in. Y equals, let's make sure we put the entire numerator in parentheses, x squared plus 3x. Close the parentheses. Divide that by parentheses, x minus 2, close parentheses. Let's hit graph. Now, it's hard to, well, I'll make sure I have the picture of the entire problem up here. I really don't see a ton. I only see the bottom part. So what we could do is we could zoom out a little bit to kind of give us a better idea. So if I hit zoom 3, kind of go towards what seems to be a magic number of 2. Okay, and maybe scooch up a bit. I don't know if that's going to help me. Hit enter. There we go. We have a better, clearer picture of what's going on. So I have this weird thing, explosion at 2, and the chart that's shown here is going to give us at 2, reappears and then goes towards infinity. I don't care about that. What I'm going to care about is my vertical asymptote is 2, and I can see that from the function itself. Okay, I can see that from the function itself. I'm going to use that information, and I'm going to fill in the table here. Now, let's. I really don't want to fill in the table, but it wants me to, so I'm just going to do it anyway. What I'm going to do is I'm going to use my calculator to plug in values so I can, make sure I have all of my numbers in. So, all right, so I think the best way to handle this is not use the table. If I were to click on table, it's going to give us integers only. Why is it not doing it? If I were to click the table here, it's, my bad, second. So I think the best way to handle this is to not use the table. Like if I were to hit second, graph, and go to table, second, graph, and go to table, it gives me integers only. Look at that, it explodes at 2. How about that? So what I'm going to do is I'm going to hit second, calc, and type out my values one at a time. Okay, so I care about 1.9. Okay, hit enter or whatever. And that gives you a value of negative 93.1. If I do the same thing again, negative 9, or second table, hit enter, and do 1.99. Okay, that gives me a value at negative 993 rather, 0.01. Okay, so let's do it again. Second table, second calc rather, value. Let's plug in 1.999, hit enter. And that gives us a value of negative 900, oh my gosh, negative 9,993.001. Negative 9,993.001. Second calc, value 1.999, enter, and that gives us negative, did I miss a 9? I did. Let's try that again. Second, 1.9999, give me strength, 9999. That gives me negative 99993. So, I'm no crazy person, but it seems like as these guys get closer to 2, your number, from the left, your number explodes down towards negative infinity. Let's see what happens when you type in the stuff on the right side, which is the 2. So second calc value 2.1 is going to give us a value at 107.1. Then we type out second calc value 2.01, and that gives you a value at 1007.01. Second value, calc rather, value. Let's type out 2.001, enter. That gives us a value at 10,007.001. And then second calc value 2.00001, got that right. And that gives us 100,007. So it looks like as we move from the left, and we can see this, everything explodes downward at 2. As we move from the right, everything explodes upward at 2. Let's go back, fill in that table, and get a nice little visual of what we were talking about. All right, so we graphed the equation on a calculator and ended with something that looks a little something like this. We had a vertical asymptote at regular 2. Okay, started up here. I don't remember exactly where it exploded, although I think it was, well, I don't know. It just exploded. Something like this happened, and then something like this happened. Okay, now, when we fill this in, we ended up with negative 93.1, negative 993.01, negative 9993.001, and negative 99993. Over here, we had 107.1, we had 1,007.01, we had 10,007.001, and then we had 100,007. Now, what this is telling us is as we go towards 2 from the left, our numbers get significantly smaller. So we could say that the limit as x approaches 2 from the left of g of x is getting much smaller as you go there, so that's going to be negative infinity. Over here, as our numbers approach 2 from the right, our numbers get significantly larger. So saying that and seeing that, we can say the limit as x approaches 2 from the right of g of x is going to be positive infinity. Positive infinity. All right. Very fun, very exciting. Next page. Now, notice this picture here. 2 pictures here. And we've probably seen it before where why does sometimes it explodes up here and ends up down there, and sometimes it explodes up here and reappears up here? How do we know what's going to be what? I'll show you in a second. That has everything to do with multiplicity. Remember in polynomial functions where you had multiplicity of 2 or 4, it bounced off the x-axis? Similar things happen here. When you have even multiplicity for vertical asymptotes only, when you have even multiplicity for vertical asymptotes, you're going to get something that either looks like this or something that looks like this. Okay, now that's vertical asymptotes only. So you'll get something like x minus 2 squared, or to the 4th, or to the 6th, or whatever. Okay, when it's even multiplicity for a vertical asymptote, if it ends up down here, it reappears down there. If it ends up there, it reappears up there. For odd multiplicity, so if I were to give you like x minus 2 to the 3rd, or to the regular invisible 1st, or to the 5th, you know, you'll either have something that looks like this, the standard stuff, or something that looks like this. Okay? That's the odd multiplicity version. So multiplicity plays a factor. Oh, I didn't even mean to, but I'm glad I did. It plays a factor just like it did in polynomials with rational functions. Now describe each vertical asymptote using one-sided limits. Okay. Well, I have 2 vertical asymptotes. So the limit as x approaches negative 2 from the left, and we'll call this f of x. Why not? I don't have a picture for it. We'll call this f of x. From the left, we're going from the left and we're shooting up there. That's going to be positive infinity. Same vertical asymptote. As I go from the right, okay, towards negative 2, The limit as x approaches negative 2 from the right of f of x is now shooting downward. That's going to be negative infinity. The other vertical asymptote appears to be 1. So as I go from the left, I'm going to positive infinity. So the limit as x approaches 1 of f of x from the left is going to be positive infinity. The limit as x approaches 1 from the right, so the limit as x approaches 1 from the right of f of x is going to also be positive infinity. Let's do it again. Now I am heading towards, so I have a vertical asymptote at 0, so we'll call you g of x, because why not? The limit as x approaches 0 from the left of g of x has me going down there, so that's a negative infinity. The limit as x approaches my vertical asymptote 0 from the right of g of x has me going up here, so that's positive infinity. My other vertical asymptote appears to be 3, so as I go towards 3 from the left, I'm shooting up to positive infinity. And as I'm going towards 3 from the right, I'm also shooting up to positive infinity. Yeah. Now this is a different problem. And if you're thinking, are we going to do a calculator for that one? How am I going to know what it looks like? I'll guide you through it. Okay, first off, it's not factored on the top in the numerator, so let's do that. So two numbers that add up to 4 and multiply out to negative 12 are going to be x minus 6. Nope, x plus 6, x minus 2. And then we have x minus 2 squared down there on the bottom. Now we're going to see this a lot more in a future lesson, but it happened to us today. We have more factors in of x minus 2. So if I write out my magic numbers, negative 6, 2, and 2. Okay. So maybe what I need to do is I do need to graph this because this is going to be seen in a future lesson, so I don't want to really give away too much. But I have like the same factor up here, but more of these down there. What does that mean? How is that going to apply to everything? So why don't we do this? Why don't we treat today as a calculator problem? Because you will see these problems in the future of what does that mean when there's more in the top or the bottom? Is it a hole? Is it a vertical asymptote? What does that mean? What does that mean? What does that mean? Let's graph it now. We'll use Desmos for this one. We'll graph it now, and then we'll come back and we'll just deal with the crazy stuff later. Okay, so let's graph it. Y equals, let's have our division symbol to make ourselves a fraction. X squared plus 4x minus 12 over x minus 2. What did I do? X minus 2 squared. All right. So it seems to me what's happening, right? It seems to me what's happening here is we have ourselves a traditional rational function. We are going to have to talk about horizontal asymptotes. We'll discuss that in a minute, but it appears that 1-ish or 1.5-ish might be our horizontal asymptote. We do have a vertical asymptote at 2. So even though there was a factor on the top and on the bottom, since there's more on the bottom, what happens is the vertical asymptote is going to dominate the whole. So this just ends up being a vertical asymptote at 2. Okay? We'll talk about that more in a future lesson. So you can't have both a vertical asymptote and a hole at the same spot, so there will be no hole. My 0 is going to be at negative 6, big surprise there. and all the other stuff is going to fall into place. But what I do know is, at first glance, it appeared that the multiplicity of 2 would give it the going in the same spot. But let's go back and try to understand why this is not going to appear that way. Okay, so the picture that I got ended up looking like this. Okay, bang, bang. Vertical asymptote at 2. Okay. What happened is, since I have a multiplicity of 2, what we mentioned before is the vertical asymptote is going to dominate the whole. And what actually happens is, since you have an x minus 2 on the top and an x minus 2 on the bottom, they kind of cancel each other out, and the graph appears to be this guy. Okay? The graph will appear to look like that. So that's why no weird double infinity multiplicity things are going on, because it's going to look like that. So my domain, since the 2 was the only issue there, my domain is going to be everything but 2. So that's negative infinity all the way up to 2, union, and from 2 on to regular infinity. My holes are there are none. Since negative 6 lives up here, right, negative 6 is still going to live up here, and now my vertical asymptote is just regular 2. So what's my hole? There is none. I'm sorry, what's my 0? I did that already. X equals negative 6. Ugh. My vertical asymptote is going to be x equals regular 2. The limit notation of my vertical asymptotes is it appears as I go from the left, I go downward. So as x approaches 2 from the left of h of x goes downward to negative infinity. As I go to 2 from the right, I go to positive infinity. So my limit as x approaches 2 from the right of h of x is going to be positive infinity. Now my horizontal asymptote, what I do to figure this out, and unfortunately I have to do a teensy bit of math, is I notice right away that this is a quadratic on the top and a quadratic on the bottom, which means I go towards a number and I care about leading terms. The leading term upstairs is x squared. If I were to do the leading term downstairs, the shortcut is you could say x in that factor times x in that factor, which gives me x squared on the bottom. Okay, and it's going to be the leading coefficient over the leading coefficient. 1 divided by 1 is 1. So the horizontal asymptote is going to be the equation y equals positive 1. And since I have horizontal asymptotes at 1, my end behavior is going to exist at 1 as well. So as x approaches infinity now, as x approaches let's do negative infinity first. That means as I move to the left, I flatten out at that 1 right there. Says x goes to the negative infinity. What is this? H of x is going to flatten out at 1. And the limit as x approaches positive infinity of h of x is also going to flat out at 1. Okay? Let's practice a little bit. In the xy plane, the graph of the rational function g of x has a vertical asymptote at regular 2. Which of the following expressions could define g of x? Well, if there's a vertical asymptote at regular 2, that means the magic number in the denominator is going to be 2, which means there's going to be a factor at x minus 2. Okay, somewhere down there. So now I can't have any repeats up here unless the one on the bottom has more. So I'm looking for an x minus 2. And looking at these possibilities, another option could be 2 minus x. Because 2 minus x still gives me a magic number of 2. So I have an x minus 2 down here and an x minus 2 up here. These are holes, so it's not going to be a. I have an x minus 2 downstairs and a negative 2 plus x upstairs. So these guys are literally the same thing, just, backwards. Since I have 2 down here and 2 down there, that's the same exact amount, which means this is not a vertical asymptote either. That's annoying. I have a 2 minus x squared down here, and I don't have a 2 minus x or an x minus 2 up here, which means you are going to be my guy. These guys gives you magic numbers at -2, and that's why this one doesn't work. Okay? Let f of x equals a over b, where a is a linear function that passes through the x-axis at -5, okay, which means a is a linear function that goes through 5, which means a 0 of 5, which means the magic number is 5, so x minus 5 down here. Looks like I don't even need to do that. I'm just going to draw it out anyway. B of x is a quadratic function that passes through the x-axis at -1 and regular 5, so magic numbers at -1 and regular 5 give me x plus 1 and x minus 5. What is the vertical asymptote of f of x? Well, u would be a whole, because these numbers repeat in the numerator and the denominator. U would be a vertical asymptote. So if my vertical asymptote is at -1, that means I have an equation at x equals -1. Tricky, tricky, weird, weird problem. Tricky, tricky, weird, weird problem. Given the graph of f, which of the following describes the function of f? So they care about our, looks like in all of these, I care about going to 4. So I care about my limit as x goes to 4. So it looks like I'm dealing with from the left and from the right. So from the left, okay, what is this, f of x? The limit as x approaches 4 from the left appears to be going down the negative infinity. So that happens. And my limit as x approaches 4 from the right is going to positive infinity. So from the left is negative, from the right is positive. From the left is negative, from the right is negative. No. From the left is positive. No. From the left is negative, from the right is positive. Cha-ching. From the left is positive. No. And the limit as x approaches -4 of f of x is 0. And that's just basically saying as you go to -4 from any direction, you're going to hit 0. That's not possible. It's stupid. Oh, is f of 0, which means if you plug in 0, it'll be undefined. No, that's just, no. Stop it. Stop. All right. What you shouldn't stop doing is liking and subscribing to my videos. What I highly recommend is you go to my YouTube and you type out AP Precalculus 1.9 and you will get to my random AP Precalculus examples. This will just give you more practice to help you understand the lesson just a little bit more. Okay, but that's that. That's the end of that lesson. 1.9 is done. Thanks for watching. Please like and subscribe. Leave a comment. Tell all of your friends. I love you. Have a great day. Bye.